Hey, I'm Prem Shankar. I work for Ericsson, and I'm working on the OpenDaylight. I'm the PTL for the project called VPN service. I've been associated with ODL probably for the past 1 year or more, both from the technical side as well as on the managing or project management side. So I'm going to today probably touch upon a bit of an important topic, which is troubleshooting OpenDaylight, right? So how many of you have deployed SDN or OpenDaylight, and any feedback on the troubleshooting? Any experiences? Okay, so so probably I'll share some of my experiences. From Ericsson, our SDN controller is basically based on OpenDaylight, and we do have a lot of challenges with respect to the debugging part of it. So what I'm going to do is I'm going to probably touch upon a couple of areas. One is specifically how do you troubleshoot OpenDaylight, and the other part is basically SDN on the whole, because I'm going to touch upon why it is very important to have an automatic log analysis to debug SDN deployment. Okay. With that context, I'll probably jump into the topic. So as I said, my agenda is more on the troubleshooting challenges. Then I'm going to touch upon the troubleshooting using a log analyzer. I'll just talk about ELK, which is the tool I've used. And then also, if you are interested, I'll run through the installation configuration and, if possible, a demo. SDN, right? So SDN, as you know, that it has multi-part, right? The one part being the apps, the other part being the controller, and the third part being the infrastructure or the data path nodes, right? So now what happens is you have different set of people trying to configure the network, right? So for example, if you're an app developer, you would be only worried about the REST conf that OpenDaylight exposes, right? And then you would tend to use it, and you would probably worry about the policy part of it. So the view you get from the OpenDaylight would basically be more myopic towards what is that you want to use, right? For example, you might have seen demos of various applications that use OpenDaylight for a couple of deployments. The interesting part is there was a use case wherein they were using it to just mark an attendance of students who are coming in, right? So what I'm trying to say is the view is multifold. You have an app view, you have a controller view, and then you have a infrastructure or the networking component view, right? So let me get into it. So typically, I would say it as app tier, which is essentially the apps and policies. Then you have the control tier, which talks about the OpenDaylight controller. And then the third one is the infrastructure tier, which is the network nodes, which is the real network nodes, right? And then when you look at it, the view differs. The logical view, I'm not worried about the intricate details of how a physical topology exists if I'm an app developer, right? And then at the OpenDaylight controller, I'm interested in how many DPNs are there, how is the topology, so on and so forth, right? So now you see that a typical SDN deployment swims through. A typical customer would essentially need to deal all these layers by himself, right? And now the problem is, from an app point of view, I would just say, hey, I want this. How do it behind the scenes is what the controller has to deal with. The controller would say, yes, this is what I think I'm going to program this flows, right? Which means now the app as well as the data path view or the network node has to be in tandem. Do you see what I'm saying, right? So I just coined a word, is you might have heard of what you see is what you get, right? So I would say what you say is what you get. So the app player says, hey, I'm saying this is what I want, right? Then the controller says, this is what I think, it's better be. And then the network node says, this is what you gave me, and that's what I have programmed, right? So now, let's assume that there is a problem, right? Things can go fine as long as there is no issue, right? The moment there is a problem, what is that you need is you need to probably get into the nuts and bolts of it, right? So when you get into the nuts and bolts, the first problem is correlation. Okay? What is meant by correlation? The correlation is nothing but my app call, my REST call, what is that it translates to, right? And then at a controller level, the calls, whatever I have composed, has it reached the node, right? The node, typically what happens is, would just go with, probably if you take an open flow, it would just program the flow calls, whatever it got from the OF plugin, right? Or if you are using netconf, you will just get the calls, right? So when we deployed, the challenges what we faced was, the problem essentially comes to controller, right? Because everyone says the controller is the one, the master, that's the one who might be the root cause of the issue, right? But it may not be true. So typically our debugging, what happens is, we basically get the node folks, the network node folks, we tend to look at the logs, right? And then we tend to look at, in most of the cases, the log gives us the exact information, but to make sure we also go to the network capture, and then we tend to do it. So that's how the typical debugging happens. Now, the essence is, if you have a 5-node deployment, fine. If you have a 10-node deployment, still it's manageable. Imagine if you have a 100-node deployment, right? Just imagine the amount of debugging or troubleshooting you need to do, right? So how do you do that, right? So the thing is, let's get into, first of all, the controller part alone. Within the controller, what are the challenges, right? The challenge being the competence areas. If you take Lithium, there are 45 projects, right? 45 different projects. And then for sure, if I'm an app developer, or even if I'm a project, I need to depend on other projects, which means that the projects, of course, are varied nature, and also I need to have the competence, right? Do I know about MDSAL? Do I know about how it goes to the OF plugin, right? In case if I'm going to the OF plugin. Then the other thing is, as I was mentioning, the correlation of events, right? Which means that NSF, I might be an NSF, that going to the MDSAL and that going to the plugin, I need to probably correlate and then see whatever I programmed is right. So this is the first problem. The problem being, as an OpenDaylight application developer, or as an OpenDaylight project developer, I need to be pretty sure I need to know the internals of it, right? The second thing is the module state detection. What is meant by module state detection? Any OpenDaylight developers here? Okay, so you would pretty much have the challenge of the Karaf loading various bundles, right? There is all probability that the bundle may load in a particular sequence than what you expected, right? Which means that now, practically what has happened is, for us, we were expecting that the bundle would load in a particular scenario. We tested it in a particular reference architecture. But for whatever reason, when we took it into a test environment, there was a bit of a race condition, or the machine was much more faster than our development model. And we expected the bundles to load in a particular sequence, but it did not, right? Of course, in Lithium, there are mechanisms to address it, but I'm just giving a classic example of a bundle dependency and related issue, right? Then the other one is the log message issue, right? So if you open the karaf.log, if you look at the sheer volume of the log, it's going to typically, it will knock you off, right? So that's the reason where you need to have some other tool or something by which you can basically do the troubleshooting, or even for the purpose, even from a development point of view, if you want to understand the call flow, you can look to use analyzer, and I'm going to touch upon that, right? So this is just the controller, right? Let's get into SDN troubleshooting. As I said, the app level talks about the NBA, the control type talks about the analysis of intermodal messages, and the infrastructure just, it provides me the device-specific logs, right? So when you look at a problem as a whole, you need to look at correlating the events, right? What is meant by correlation? I made this API call. Yes, it has landed on the OpenDaylight. Yes, it has come on to the MDSAL layer. Yes, it has reached the plugin, the southbound plugin, and then I do see that message coming into that of the device, right? So you need to correlate this, which means that you need to, if you are using OVS, you need to open the OVS logs. If you are using the OpenDaylight, you need to use the OpenDaylight logs, look at the timestamps, and then see what's happening. Right? So what is that? What is the way out here, right? So why is that? Is there any other method other than log I can use it, right? So the log analyzer historically has been the best way to debug any issue, right? In fact, in many of the deployments, you also use log analysis for any security issues or any security violation, right? So which means that for sure log analyzer has tons and tons of information, useful information, right? And it's also extensive. That's the most challenging part. So what can I get from a typical log analyzer? If my ODL log, I can get a module startup, I can get state transition information. What is meant by state transition information? If you are an app developer or if you are a module developer, typically what happens is you would have a state mission for your app, right? The state mission depicts whether your module or an app is in the right state or not, right? A failure state is one wherein you are in a particular state and that particular state is not the right state. That is where you call it as a failure, right? So which means that the state transition information is key to me, okay? And then, of course, the exceptions and errors, just to ensure that the error is not the root cause for any problem, right? So for sure, log is going to be one of the important ways, okay? So what's the conventional method? The conventional method, what we do is we basically use tail, awk, sed, a mix of these tools. If you look at any of the network admin or DevOps guys, before Chef or Puppet came in, they would have a bunch of these tools to debug, right? But as I said, it's time consuming, right? And the other problem is the correlation is difficult. Why is correlation difficult? I need to have one window for my OpenDaylight, I need to have another window for my OVS, and if I have OpenStack, I need to have another window for OpenStack, right? So what is the solution out, right? Okay? The solution is going for automatic log analysis. How many of you are familiar with automatic log analysis? Okay, so I think probably you can help me out in case if there are any tough questions. Thanks. So this particular automatic log analysis is a market by itself. There are a bunch of startups which has their business model around just log analysis. From outside world, they would say we are doing X, Y, Z, but behind the scenes, they typically use these tools to build their products, okay? So one of the well-known product is Splunk, but that's a commercial one. And the other open source equivalent is called the ELK, okay? ELK stands for Elasticsearch, Logstash, and Kibana, okay? So the idea here is using this automatic log analyzer, what you can do is the one other advantage is it supports a wide variety of plugins, right? From a flat file to that of Log4j to that of anything, right? Even your Twitter feeds. I'm just giving an example of how powerful those log analyzers are. And then what happens is you can do a bunch of transformation and visualization using these tools, right? And other thing is you can also build some rules that can help you a proactive fault detection. What is meant by a proactive fault detection? A typical example would be a state diagram, as I was mentioning. You can probably write a rule saying that, hey, this particular module, if it's in state, it has to have these conditions. If not, alert me, right? So this is one example of where you can go in for a proactive fault detection. So, and then one other thing is, this is one of my pet projects which I've started internally. And I would say it as a multi-phased approach. The first thing what we started was we just started ELK to do the initial level of log analysis. Then we wanted to get into correlation. What is meant by correlation is use ELK to process ODL logs, to process app logs, to process OVS logs, and then correlate or try to do a correlation between them, okay? And then once that is done, I wanted to also take machine learning into consideration, wherein you can have these texts, unstructured text be passed or structured text be passed, trained. There are well-known open source thing like WKA, which is available, which you can use in order to do more of a machine learning type of thing, wherein you can typically predict. For example, if you look at it, right, most of the bugs or most of it is, you know that this is the step 1, 2, 3, and 4, and fifth for sure, if it's going to be the step 4 is going to fail, the fifth will fail, right? You can also capture it in a way that you can train the system and then say, step 1 seems to be good, but it has some problem. So step 2, not so good. So step 3 for sure, you can hit the failures, right? So what you can do is you can always proactively say that, yes, there is a failure, right? Or you can also do a restart or some preventive mechanism. So let me get into ELK. So what is ELK? As I said, ELK is basically a combination of Logstash, Elasticsearch, and Kibana. Okay? So you do have the logs available, right? It would be of your own format, right? And other problem is pretty much the log that is generated is nothing but what the developer wanted to convey, right? So which means that the first challenge is it might be cryptic, we can't help it out, but one thing what we can do is through Logstash we can transform. So OVS may log it in a different format. OpenDaylight would log it in a different format. So what you can do is you can basically, using Logstash, you can transform. Then what you can do is you need to persist. Persist for what? To get statistic analysis, right? For example, how many times did I see this error? How many times did this particular condition occur, right? So for sure persistence is needed. And then another thing is the analysis. The analysis is when you would take decisions on how would you essentially take any proactive decisions, right? So that is where the analysis provides you a bit of tools like pie charts, number of, like a bar chart depicting the number of occurrences and so on and so forth, right? So with that, I just wanted to pass any questions, any thoughts, any feedback. I mean, this basically, as I said, it's going to help the development community as well as the deployment community. So please feel free to, yes. Okay, so the typical issues what we had was, the one important issue what we had was with respect to the OF plugin. We expected that the call flows would be of a particular nature. Okay, we did send it, but then on the device side, in this case the device was proprietary, we did have some OF plugin extensions. So the device was expecting in a particular format. Okay, and then when we sent it, we assumed, because we were open flow compliant, right? Whereas the device, they were not. Just, I mean, this experience we got it from, we did interoperate during the ONF conducted an AppFest. As part of AppFest, we took our controller and then operated with various other open flow switches. So the typical issue we faced was, we always assumed that the device would implement the open flow specification as is, right? But in most of the cases, the interpretation would be different. So we basically used to capture the differences. That is one. And the second thing is, we did have a couple of other teams developing the applications. So they used our RESTconf, but then the RESTconf invocation was not in tandem with what we expected. So these are the two scenarios where we use this to debug. Yes. 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 We did do with Greylog, but from the feature-rich point of view, we felt ELK to be a better one. So that is where we thought we will go with ELK, because there is also a community around ELK. So that's the main reason we went with ELK. And by the way, there are already other proposals that's that's there from the OpenDaylight perspective. There is one proposal wherein they are basically using Greylog to push alerts and events into MDSAL. But this particular approach is non-intrusive. What is meant by non-intrusive is you have OpenDaylight, you're not going to make any code changes. You have OVS, you're not going to make any code changes. What you're going to do is you're basically going to just configure the ELK stack to get things done. Okay, yes. Yes.
You probably know in all new young models, we include telemetry.
Yes.
So at some point, models in MDSAL will know what's going on, and there might be some faulty condition. How are we going to extract them into something like syslog message?
Right. So now there is to answer to your question, the ceilometer would essentially get some events from that of other sources. Typically from an OpenStack point of view, ceilometer uses it for health and for other parameters, right? So now what happens is, from OpenDaylight point of view, we don't have any support of sending the events back to OpenStack. But what you can do is you can always look to have a plugin for syslog. There is already one. So you can do the analysis independently and then generate events what ceilometer expects. So you can transform and then generate events what ceilometer expects. So that's an out-of-band approach, right? So as I said, it is an out-of-band approach, nothing intrusive, no code changes to existing deployment. Because the thing is, if you're going to make any changes, you need to do customization, so on and so forth, right? And again, what I'm trying to say is this is an approach to it, right? And also, you need to build a bit of competency around understanding how would you transform, right? It doesn't just come as an, you take it, integrate it, and then start using it from day one. The advantage is it's a one-time investment, wherein you invest in customizing ELK for yourself, and after that, it's going to be a smooth run. I hope it answered your question. Okay. We can probably take it offline. Yeah. Okay. So with that, let me further get into ELK. So as I said, Elasticsearch, basically they store the data that Logstash processed and provide full text index. Logstash, it is used for collecting and parsing log files, transform unstructured log into meaningful and searchable. Kibana, it's a web console for user to interact with Elasticsearch. So I'm just going to get into the components. What does Logstash mean? So Logstash mean what it does is, as I said, it provides transformation. How does it provide transformation? So it takes input as a particular file format. For example, it takes a flat file, syslog, log4j, redis, WebSocket, so on and so forth. Then the filter. The filter is basically, you can filter out noise, and then you can also basically transform. What is meant by transformation? This is what I had. I know that, for example, a simple pulling of an Ethernet cable would generate bunch of events, right? You don't want to basically generate all the events and then try to process it. What you can do is you can probably do a count of it, do a transformation, and then output it as, so that what happens is the output, whatever you're getting, is not voluminous, or the output is much more meaningful so that you can perform some analysis. So that is where the filter is the one that transforms, okay? And then what Elasticsearch does is, it does a mapping of, this is what, for example, at time, okay? You can say that this parameter corresponds to time. You can configure this parameter corresponds to a source port. You can configure this parameter, or this particular item in this column corresponds to a destination port, right? You map it, then it also provides you search. The other one is aggregation. What is meant by aggregation is, as I said, you can aggregate saying that how many times did this particular event occur, right? You can bucketize, or you can say, these are the get calls, this is the number of get calls I got, this is the number of put calls I got, or for example, a typical flow mod message, this is the number of flow mod messages got. So it basically segregates or aggregates. So by aggregation, what happens is, it helps Kibana to do analysis. right? Just to reiterate, the Logstash again does the transformation, the Elasticsearch does the persistence, and then the Kibana, using the persisted data, it basically discovers and it helps you in visualize. Right. Yes. So now what happens, the tool is just a mechanism to filter it out, right? But you need to write the logic. What you can do is you can basically say this particular message, for example, Ethernet cable pull, right, which would essentially bring all the logical ports down, so on and so forth, right? So that particular logic, you have to build it, okay? But then you can generalize saying that, as I said, the first step is transformation. The transformation you have to do, right? And or what you can do is you can very well do it in a very dumb way, saying that just log everything, okay? And then no, you just point it to the log file. The tool will do it for you. Just to give an example, let's assume you're using log4j. What you say is just connect to log4j, and then in the Logstash, say that I want to read the log4j, no filter, no transformation. The output is just Elasticsearch. I'm talking about a very, very rudimentary, simple example, which also I'm going to show it. And then the next step is everything comes to Elasticsearch. Here, you can bucketize, right? You can bucketize saying that, okay, this is the message, I want to put it in as this particular category, right? Or you can just ignore also, right? Let's assume you don't want to do anything, right? At Kibana level, you would have categorization automatically, right? Kibana has, you can give regular expressions. In Kibana, you can say, hey, just tell me what are the log messages from this time to this time. Okay, or you can say, how many times does this particular event happen? So the example I'm giving you is very, very simple and rudimentary, nothing drastic. You're not going to make any change. Downloading the tool, just pointing it to the log and then seeing it. Yes. 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 You can do that, yes. You can do that. That's the simplest one, yes. Okay. So let me get into a prerequisite. This probably would solve you. So for a prerequisite, what we did was we basically edited the configuration file. We just changed the root logger line to info out, and then that elk transform is basically the one that would essentially help me. That's a key. What happens is there are log4j configuration files, and then what I do is the appender, the log4j appender basically does use the socket append, and then it starts. Typically, we listen on the port 9500, and once the transformation done, I'm just using the local host, and I'm pointing it. This is just the prerequisite which you need for OpenDaylight. And then from a Logstash perspective, you can just spend 10 minutes or 15 minutes and get it done, right? Just download it, install that particular package, and then just start the Logstash daemon. In the Logstash, what you do is you have to just you have to edit the caraf.conf, add this particular input. The input, as I said, this is a transformation, right? So the input is a log4j, the mode is server, and the port is 9500, and then I'm not doing any transformation. I'm just outputting it, and my output is Elasticsearch, and the host is localhost, and then I start my Logstash. Yes. So I assume that the apps are sitting with, or it is using the same the OpenDaylight logs. So if you want to do separately, then you need to do similarly for your apps. So you need to do a similar thing for app. You need to do a similar thing for OVS. Okay, that's a step by step. The first is get them for each of these components. Then you can build your correlation engine. Okay, as I said, you need to have a bit of competence because it's a one-time activity. But once you're done, you have the framework ready. And then on the Elasticsearch, just edit the Elasticsearch YAML file and then point the network host to the local host and restart. And Kibana, it's pretty much the same. You just add the port and then change the host to localhost. And that's what, I mean, typically this is what we got. So this is the message, or this is what we have captured, wherein if you look at it, this is based on the timestamp. We just get all the messages. It captures the host, the bundle name, the priority at that particular point of time, the logger name, the thread, and then the message. What was the message? Okay, no transformation here, as is. And then we also did a bit of analysis. We just wanted which is the top 20 bundles that basically is hogging or generating this. Okay. So let me quickly see if I can demo that. Actually, I had overloaded my VM and then it was not responding. So no, okay. So I'm sorry. Otherwise, I would have showed you the real. I can probably show it off after this session. Okay. Okay. So thank you. And any other questions, suggestions, thoughts? Yes. I'll. Okay. Yes. Usually, karaf.log has most of it. The karaf.log. Yes, that is basically it rolls, the log rolling happens, and that is where it happens. So when you start it, it would start from that instance, and then it will collect all the logs. So what it does is it does it real time. So it has its own persistence. So it will basically get the transformation done and store it in its own persistence. Yeah. Right. Okay, so so what we have is we have a bit of monitor threads that would essentially look at the clustering issues, and then what happens is it would essentially ensure that we have a bit of a hello message type of thing, and then we would resyncing, and then that's how we manage it. Because the problem was in hydrogen everything was fine because with InfiniSpan you could monitor or you could have a central place wherein you can use. What we did was in case of hydrogen we were creating objects. If an object is created, then we know that you wait or you are ready to go. But if the object is not created, you need to wait until it is created just for synchronization. Mm-hmm. So with this, no, this is actually independent of it, right? Because the tool does not know whether a particular module under analysis is, it is totally unaware about anything. So what it expects is, it expects constant stream of messages from a particular source. That's all. Beyond that, it can't do anything. That's where I said it is outside the paratext of OpenDaylight. Right. So we have internally worked on a bunch of correlation, but then the one correlation is what we do is what happens is we expect certain table to be populated. So we get that message from that particular logger to see if those entries are created, then proceed, right? So what we did was we used this to analyze whether the pipeline programming was proper, right? Whether flow mod messages were proper, things like that. But beyond that, to answer to the specific question whether this was taken as an input, no, we didn't take it as an input. The use case was pretty much on three things. One is the flow from that of the applications to that of controller, then the flow from controller to that of the device, and then the feedback, whether it's programmed and the states are correct. So that's the use cases we have used it for. Any other questions? Okay. There are no questions. Thank you. Thanks.